realized, and when I uploaded on YouTube, I realized I don't see how my students listen to me for 16 weeks. And I think that there needs to be a drinking game where every time I say students have to drink, but then they would probably be drunk within 15, 20 minutes. So I realized that I can't stand listening to myself being recorded. But you know how it is, we're gonna write code. That's all my life right here is we're gonna write code. I do have your text over here on the right-hand side. I hope that's okay with everybody. I realized on the last recording that I uploaded to YouTube, those weren't on there. So I would have long pauses where I would be talking to students via text, and it would look like I'm just dumber than I am. So I'm going to leave these on here. The other thing is I did switch keyboards. So I got rid of my mechanical keyboard, which is breaking my heart because I like my mechanical keyboard. So hopefully it will not sound as annoying. So let's start a new project. The other thing that I realized, and this is amazing how things don't occur to us, is I did not think about students. Some are watching this, don't have two monitors, don't have two devices, maybe watching it on their phone. So your guys' environments out there are going to be very, very different. And so I'm going to have to adapt to that. I mean, some of my students yesterday were watching it on their TV somehow and typing on a computer. So if you have access to two devices, that's wonderful, because I honestly believe if you type along with me, you get to create something and it registers. But if you don't, that's okay. You can watch the video. It takes me a while to get it uploaded, and you can type it in later. I won't require it today, but in every single class, we're going to do some kind of work, and I'm going to have you guys upload it, because we have to have some way, especially with a take-home, to make sure you guys are learning this stuff. And so what I want to do is I want to learn about simple interrupts. That's what I want to do here. So I actually have one right there, but we're going to type it from scratch. So I'm going to save this. And this is going to be simple interrupt example. All right, I made the font bigger, so hopefully you guys can see it okay. I can make it larger if you want. I can, if I'm going too fast, you got to tell me to slow down. I can't see anybody's expressions. If I say too many times, there's not a lot I can do about that, but I'll try, okay? Now, what we want to do is, if we're not using interrupts, and you would see this in the real world, is what we have to do is we have to do some kind of loop where we're don't type this, constantly checking, right? Just constantly checking and checking and checking to see if something happens. And so it gets really complicated. Anybody that's done Arduino programming, you'll find that with, if you, I don't know, you run into issues unless you start using the interrupts. The other thing is sleep is a problem. So if we use the sleep or the delay, if we use the syscall 32, so we just pause everything for whatever milliseconds, that's a problem too, because we can't do anything during that time. We're host, okay? So what we want to do is we want to take advantage of the ability of Mars or any computer system to handle exceptions or interrupts. And exceptions or interrupts, you learn this a little bit in Java, maybe. You're going to learn a lot about it when we cover chapter 4. So interrupts and exceptions are similar and different. Some can be divide by 0. That's an exception. And an interrupt can be something that happens on the outside world. It says, hey, I'm here, do something different. That's kind of what we want to get into now. To illustrate how handy an interrupt is, and we're going to look at the counter that's in this digital lab simulator. So if I go help on this thing, down at the bottom, there's this thing called counter, okay? And what we want to do is we want to utilize, not that, hold on a second. we want to utilize this counter that will throw an exception every 30 instructions, and it will allow us to do something different, okay? So the byte value at address this FFFF0013, if one bit of this byte is set, the counter interrupt is enabled. The counter interrupt is every 30 instructions an exception is thrown, okay? Now we're going to learn about these cause registers. I'm not really worried about that right now. We're going to learn about that. This is over here. Many, many different exceptions can happen. So there's a register that when you throw an exception, you put the value of your exception in there, and it knows, and then you can evaluate what happened. I mean, you could have like 6 or 7 different things going on at the same time. And when something goes awry, in Java, you guys deal with that with your different types of exceptions. What is it? Array out of bounds, divide by 0, those things like that. So what we want to do is we want to do a simple example of how we can utilize that exception thrower in Mars using this digital lab simulator, which we'll need to connect. Now remember, it said we need this right here. So let's start with that. And so we're going to do a .equiv interrupt bit, and that's going to be 0x12340013. All right, if set interrupts are thrown. Okay, so that's the first thing. So let's do our .text, and I'm just going to do some stuff just to have, so we have stuff to play with. All right, so I'm going to do loaded T0 0, load immediate $T1 0, load immediate $T2 1. Okay, now this is going to make me forget what I was using it for. So that's how bad this is right here. This is going to keep track of my interrupts. You'll see how it plays in a minute. Okay. This is did anything change? And I'm hoping you guys will see what I'm talking about right now. This is what I'm going to use to set my interrupt so something happens. All right, so that's right here. So what I'm going to do is I'm going to do load immediate $T4 interrupt bit. Okay, so this loads the address of the interrupt bit into the register. So now I can do indirect addressing. I can actually set it so interrupts will happen. So then I can do store byte $T2. I got to change something because I'm going to get really confused here in a minute. So this is what I do. This is how I set my students up for failure. Is I start typing and then I change something and I don't tell them, and they're like, well, why doesn't my code work? And it's because I'm a sneaky old man. Okay, so what we're going to do is we are going to enable interrupts. That's what we're doing right here. So remember, T3 has a 1. T4 has the address in memory that we have to set. So when we store the byte, the value 1, into this memory location, there's my base address, there's my offset, then I have my interrupts enabled and I'm good to go. Hey, life's good. So what I'm going to do is I'm going to do a loop, because we have to be in this loop forever. So we're actually doing something, and this would be branched loop. So I can be talking to myself forever, which seems to be what I do these days. But I actually want to do something in that loop. Okay, I want to see if things changed. Well, the only way things are going to change is if an interrupt happens. Okay, so this is where my logic is going to go. Okay, but this isn't where my interrupt is going to go. So we want to add that interrupt code. So down here at the bottom, .ktext. Okay, so this is different. This is where we go when things are out of the normal. Okay, that's where we go. Now we do have to give it an address, and this is really important. 0x8 1 2 3 4 5 1 8 0. And let's see if I typed it in wrong. I think I did it wrong. Is that 4 and 4? No. Okay. So that's the address. So that's what that does, is that says, okay, you know, when things go wrong, I'm going to go to that instruction. My instruction counter will go there. Okay. So what it'll do is it's going to jump anywhere, no matter where you are in this code. If you're on line 11, 12, 15, 19, no matter where you are in that code, it's going to say, I'm done. I'm going to jump down to my exception routine, and I'm going to do whatever I want down there. So then I'm going to do add immediate, $T1, $T1, 1. And then I'm going to return for my interrupt. Okay. So I am going to simply update something. All right, just to make sure we know. And now instead of jump return $RA, and that's how we normally return from our subroutines, we are going to do an exception return. So we're going to return to where it was left off. And there's a lot that we're going to have to learn about, not in depth. We're not going to, I mean, we'll spend a day, maybe a day and a half on this stuff. So it's not where we're going to do whirlwind, but we are going to understand a little bit. If you look up here where it says EPC, so that's the exception program counter, that's where it stores where the exception happened. So if it happened at line, were we at line 15? Were we at line 18? Obviously they would be program counters, but that is where we go back. We have a cause, we have a status. We're going to learn about all that stuff. So this right here is simply going to jump down here and then go back to wherever we were. Okay. So what I want to do is I want to actually enact change. So we're going to do branch equal $T1, $T2 loop. All right. So what we're going to say is if $T1 equals $T2, nothing has changed. Okay. Because right now, what do they both equal? If I did it right, T1 and T2 both equal 0. T1 equals 0, T2 equals 0. So unless somehow we get down here and we actually modify something, these will remain 0 forever. Okay. So what am I going to do? I want to print it. If I know that they're not equal, then I know something happened. Well, for right now, how am I going to do if something happened? I'm going to move to $A0, $T1, okay? So let's get ready to print. And so load immediate $V0, 1, right? And if I was OCD, which I should be, normally I am, I would be doing stuff like that. Okay, so this is our syscall value that we need, syscall. So what I've got is if T1 is different than T2, that means somehow we got down to the exception, okay? And since we got down to the exception, something changed. Now, then what I have to do is I need to set $T1 to $T2 so I can wait again, right? So I'm going to challenge you guys. I mean, I talk to walls and all that other stuff. So I'm going to ask, can someone give me the code? And there's so many different ways to do this. To set $T2 equals $T1. Because now that we printed it, we need to update T2 so it equals T1 so that we can wait for the interrupt. So I am going to stare into space, and I'm hoping that someone is feeling brave and can give me a command where it will assign the value. And there's a bunch of different ways. There's pseudocode. I can start calling names because I see all your names, but I don't want to lose people. Okay. I'm waiting. I'm scared. No one's going to do it. 6 million different ways to do it. Move works. Move is good. Thank you. So one way is to do move. So we can just simply move T2 $T1. We could do add immediate $T2, $T1, 0. Okay, we could do or immediate. So we could do or immediate $T2, $T1, 0. So there's lots of ways to do it, and I appreciate that. So T2, $T1, okay, set them back to equal so we can wait, all right? And then what is the last thing we do is we go back to my loop, okay? We're never going to get here, but I'll do load immediate $V0, 10 syscall. Okay, so this is our code right here. Now I'm going to try something, and we'll see if it works or not, is I'm going to try to annotate, because I'm learning this stuff as you are. So remember, what we're doing is, I don't want that over there, I'm going to put it over here. So our code is going to continuously loop until, as long as these two are equal, okay? Now, when the exception happens, when anywhere this goes, it's going to say, all right, I'm going to jump down here. So it's going to jump to that spot in the code, and it's going to execute the code right there. There's a lot more that we can do with this. We should be checking this right here. We should be checking the cause and saying, okay, what actually happened? I'm looking for a highlighter. I didn't want to clear all my annotations. So anyway, and then what it does, I don't want to erase. See, I'm learning this stuff, and I should have just stuck with it. And then what it does is it's going to do this right here, and then it's going to go back to whatever address this is. Okay, so when the exception happens, no matter where it is, it'll jump back here. And then what we do is we do our logic so we can actually display it to the screen, and life is good, okay? So let's try it. Now the thing right now is we're not connected, so it's not going to do a darn thing. I am going to slow it down. So I'm going to slow it down to 29 instructions a second. Now remember, on this thing, it throws an exception every 30 instructions, okay? So let's see how many errors I have. I must have an error, and my screen's messed up. I hate when this happens. What did I do wrong? Oh, I probably did not comment out something. I need to exit Mars. Meeting recording is in progress. Why does that say that? Where is my error? Oh, right there. Okay. All right, let's see if that fixes it. All right, so we've got it right there. I don't see my output. I don't know how to fix this. Here I am, I've been doing this stuff for a long time, and I don't know how to fix this. So I'm going to exit and get back in. If anybody knows how to fix it, tell me. But I have to do this. This shows you how dumb I am. This is simple interrupt example.asm. So I'm going to kill it. That's what I do, kill things. Okay. And every once in a while I mess up my screen and I got to start over again. So this is going to open, and this was whatever the hell I called it. Whatever the heck I called it. Okay, and we're going to need our tool. We're going to need our digital lab simulator. All right, boy, that was long-winded, right? We're already a half hour in. I'm going to run out of time. So we can compile it, and I can start running it, and it's not going to do anything. Okay, it sits right there. Now, if I connect to MIPS, now it's going to start doing something. It doesn't look like anything's going on, but it's doing these instructions, okay? And if we get to 30, you're going to prove me wrong, aren't you? Okay. Am I connected? Oh, I'm going to be so upset if I messed up. And I probably froze it. All right, what did I do wrong? So disconnect from MIPS, reset. It worked before. Loading me interrupt, set bit. Oh, it's doing something because I went here. You know, this teaching online is going to, I've lost a couple people already. I'm sad. And I just froze it up because I forgot to reduce this back to 30. And so now it's frozen up. And I hope you guys are patient. And so I'm going to kill it. And I'm going to start over again. And I'm going to try and use my brain. And I can always do death by PowerPoint. That's my universal answer, is when I start messing up like this, I just say, you know, let's just watch PowerPoint. And then I'm the perfect teacher. I am the perfect teacher. So tools, did anybody get to work? I really want to know if anybody got theirs to work and are sitting there 30 seconds, or if you guys are all like me where it's frozen up. So repeated that loop. Yeah, let's see what it does now. There we go. It's doing something. See down here, 3, 4, 5, 6. So what it's doing is, yeah, so Patrick, we got to figure out, maybe look at your code and see what you missed. I know I might have made a mistake, but I had this down at 18. So what it's doing is it's going to execute these instructions, and then on every 30th, let's watch what it does. I can sit here and type away, and you saw it jump. So it jumped down here and it added. So T1 down here has gone to 7. And now it's going to jump back. It's going to print, and then it's going to continue their loop again. And then when it gets down there, it'll jump, and it's going to do the exact same for me, and it'll print it again. Okay? So this, you know, it's going to go on Canvas. I mean, what we're doing right now, I'll take my code, and it's going to go right in here somewhere. I'm probably going to create a page because this is going to get really cluttered, or Professor Halim will help me because she knows how to do this stuff better than I do. But we'll create a page and start putting this code in there so it doesn't get all cluttered. But that's just a real simple example of a basic inlet. Is that clear as mud, or just a way, you know, it really is just a way to control, just to control sequence, right? Branching, this gives us a way to jump around, okay? Any questions? Okay, let's do a different one. So I'm already down to 141. We're going to write one more so we can look at a different example on, and then Monday we'll start really diving into this stuff. So are you guys game to do one more really quick before I run out of time? So this works. Again, I'll post the code. You can look at it. So let's look at one more tool, okay? So this is going to be simple MMIO test. And if you look at this, it's not going to seem very exciting right now, but this is something that you can do in your final project that's kind of really cool, okay? And we're going to do it, yeah, I'm going to run out of time, but let's see how far we can get. So this, we're going to mess with this tool, and it looks the most boring thing ever. But what this is this gets us to a visualize input, and then we get to display it to a text screen. I don't remember if I said much about that on last time. I think I brought this up real briefly. But what we want to do is, this is a different tool that we want to play with. And so if you're interfacing with equipment, so let's say that you go to work at Intel and you have to interface with one of their semiconductor devices. So you've got to be reading data coming in, and you've got to respond and write data back to it. So this is an example of what we want to do there, okay? So this one here, let's create one real quick and see how far we got. So .equib, this is THD, and I'm going to go really short on these. Okay, so this is where, oh, I can't type. Okay, so if we want to write data so it shows up on this screen somewhere, this is the memory location that we're going to use to write data to. So this is transmission data right there, okay? And so we're also going to use .equib transmission ready, all right? So this is 0x12341238. And this is where we check, is the device ready? All right, so when you're interfacing with equipment, what you have to do is you have to say, hey, are you ready to receive information? And until they tell you that you're ready to send information, you don't. When it does say, then you send the data. The exact same thing happens with your keyboard, okay? Your keyboard has to say, are you ready? If we go back to this right here, let's see if anybody's out there still. Which one of those codes deals with sending and receiving data? There's actually 4 of them. There's 4 of those codes in our simple decimal ASCII chart. I know you guys have to know that from CSC230. And there's a bunch. Does anybody recognize any of those codes that would deal with sending data from one to the other? Oh, I thought I would check. So this is acknowledge right there. That's acknowledge. Hey, are you there? This, that's our sorry. This is inquire. Hey, are you there? This is acknowledge right there. This is start of transmission. This is end of transmission. So even in ASCII code, when you're sending data from your keyboard or you're sending data to any device, you have to say, hey, are you ready? And if they say, yeah, I'm ready, and then you synchronize and you start sending data. So that's what this is all about right there. Now we also got to read data. Okay, so we're going to do and this is key code, and this is 0x, and this is where we're going to read the data. So we're going to read the data from right there, and it's the same thing right there. And this is key ready, and so this is 0x1234 1234. Okay, so in our MMIO, in our memory, this is the addresses that we can use to read data. All right, so and what's nice about this that we cannot do with our syscalls is this is instantaneous. So the minute you type in a key, you can respond and do something. With syscall, you say, hey, give me data, and then you wait for somebody to hit return. And when you're waiting for them to hit return, it can just sit there forever. So, what we have to do right here is we have to use our text, main, and I didn't even type that in last time. That's horrible. Load immediate, $T0. And we got to get our addresses. This is key code. And this is load immediate T1. This is key ready. And this is load immediate T2. TH data, and this is load immediate T3, and this is TX ready. Okay, so these are Okay, so now what we do is we have a way to get data from here and read data from there. So we're ready to do it. Now we're not dealing with interrupts here. So when we go back and hopefully at some time we can mess with this with interrupts, and I can show you guys how to do that. We'll have a day in class when we do this. We're not doing interrupts, so we have to do polling. Okay, so we have to do polling where we just constantly checking. Okay, so instead of just saying, hey, I'll be here when you call, I'm always doing push. Hey, you got anything? Hey, you got anything? Okay, think about that. Think about your friends. If they're always texting you, say, hey, you got anything? Instead, you just want to say, hey, you know what? Don't talk to me. I'll tell you when I'm ready. So what we're going to do is we're going to do load word $T4. And I have an error. Where did T4? Oh, I love it. So let's do load immediate $T4 1. Okay, so when we write a 1, that means that it's going to say, hey, is anything there? 0 $T1. Okay. And so what that's doing is it's going to tell me if something is written. So we're going to say, hey, I'm going to send a 1. You're going to tell me if something's written. And then what it's going to do is oh, no words. Oh my God, I'm brain dead. Load word. Loads from memory into a register. Oh, send me home. This is going to be a fun semester. I don't need this. So what I'm doing is I'm going to say check. Hey, I'm going to check this memory location. And it's going to tell me what it's going to do is if anybody types something here, if anybody types an A, then it's going to write something to that memory location and saying, hey, I got data. It's here if you want it. Okay. So this is the same thing you guys have seen before. So branch equals 0 $T4 loop. Okay. So if nothing in the keyboard buffer, then just wait. Okay. But if something does show up, then we want to do something with it. So we're going to do load word $S0 $0 $T0. Okay. So we're going to read the key pressed into $S0. So we now have the data. So this is key ready, then let's read the code. Okay, that's what's going on right there. So we actually have some data. Okay, now we want to write it over here. But again, we have to do another loop because we can't write it until that one's ready. And I'll give you some slides that'll talk about this right here. But what we're going to do is we're going to do load word $S0. I lost myself. Might help if I know what I'm doing. So this is going to be load byte $T5 0 $T3. So what this does is it actually sets a byte if you can write to it. So this up here, and this one's more complicated than I thought it would, but let's see how far we get. So this sets a bit if you can write to it. Okay, don't get scared away. When we get to Tuesday, Monday, and Wednesday, it's back to just very, very carefully walk you through what we need you to learn. This is just kind of exploring a little bit. So it's not going to be this ugly later on. Just ride with it for now. I know I'm losing a few people and that bothers me. So what we're going to do is, are you ready? Okay, and this is branch equals 0 $T. There's an error right there. That's 5 T5 right loop. Okay, so keep checking to see if I can write. Because if you look up here, there's this delay thing right there that says, hey, you can't write to me until I'm ready. And there are. Equipment basically says you can't. So then this is store word, $S00, $T2. Okay, so I can write to the display. That right there. And then I do branch loop. Okay. And then this right here is load immediate $V010 syscall. So what this is doing right here is we've got our loop and we're doing some loops inside of it. So what we do is we have one loop right here that says, hey, do I have any data? And it just keeps waiting. And then when it does get data, then I load the data into S0. And so that says, hey, I've got data in my register now, got it in S0. I want to write it up here. I could just display it, okay? I could do this. I could do move $S0, oh, sorry, A0, $S0, load immediate $V01 syscall. So just to see, I could print it, which is good, okay? But then I also want to write it out to that other screen. And so this involves another loop where I have to continuously load the byte and check and then keep going. Now the problem here is I'm going to move this because that would print it over 6 million times. Okay, so we're going to put that there. Sorry, guys. All right, so we're actually ready to go here, believe it or not. And so who knows if it'll work. I will post this. So again, what we're doing is we're showing how we can instantaneously read data here by pulling. And we pull it, and when we get data, we're going to display it to the screen down here. And then we're going to write it up here. But we can only write it up here when it tells me we can write it up here. Okay, so I'm going to save this. And I should have saved it earlier. So this is simple MMIO test run.asm, whatever, if you're typing along, or you can type it later. I'm hoping you guys will mess with this because this stuff's cool once you start playing with it. But then again, I'm a nerd and I like nerdy stuff. Okay, so what we're going to do is I'm going to compile it, and I have an error. Write loop. What did write loop. Oh my God. All right, I'm ready to go. Okay, so I'm ready to go with this thing. I'm not connected. So if I start running this, it's not going to do anything. It's going to sit in a loop. So I'm going to do connect. And I'm going to start just to show you. And I get in here, and all it's doing is sitting there. So if I come in here and I type a B, that means that it should do something. And it did. So what it says is I've got data. So if I come down here into my MMIO, there's a 1. That 1 right there said, hey, I got data for you. The 62, that's ASCII code for a B. So it read the B right there. And so now what I can do is I can continue on my merry way. I printed out 98. I got to figure out what I got going on there. Oh, B is ASCII code 98. I'm so smart. And then what it should do is it wrote it up here. You notice there was a delay. But what I can now do is I can run this, and the minute I type something in, okay, it does here. Okay. Now I'm not going to get to it today because I'm running out of time, but this is for games. If you ever wanted to create a keyboard game, you can send different codes that moves the cursor wherever you want. You can move the cursor up, down, clear the screen. You can make it do whatever you want. So if you guys, who's my gamer? On gamers, is it AWSD or is it JKIL? If you're playing a game on the keyboard, my day, I thought it was ASDW for Halo or Half-Life. Do I have any gamers that can share with me, if you're playing it on the keyboard, what keys do you use to move? Anybody? WASD? Yeah, so that's what, yeah. And I wouldn't be able to do that now because I can't use one of my fingers because they stuck it in the circular sign. So I would have to use different keys. I would have to. I still have them all, just one doesn't move. How's that for too much information? So yeah, this is the same thing. You can create a game, and what you would do is you would write the program so that if somebody types in an A, a W, S, or a D, then you would move either the bitmap on that bitmap display, because we could be controlling a bitmap and moving that, or you know, you could create a game at an assembly level where you're playing, what is the old game? Asterix or Asteroids or something like that. Next time, what we're going to do is we'll continue with this when I can have special sections if anybody wants, or we also will continue in class. We'll build on this. But I have another example. If I show you that one, this one right here is cancel, open. This one right here is the same program, but what we do is we can go home, which clears the screen. Or this one right here goes to a certain location in the screen. We'll show you how that is. This goes to a specific location. It's really cool. On my locations, that's one location. That's the other location. And then this is the code to tell it to move. So there's some cool stuff there. So yeah, that one right there, if I run it, A, B, C, D, if I hit escape, and then I type, it doesn't do anything. Oh, it might help if I run the program. And then if I hit escape and type, it goes there. And if I hit tab, it clears the screen. So we'll have fun with this. All right, I've talked gibberish for 45 minutes. I apologize for having to run away, but I do. Did you guys have any questions on just the real simple stuff? The interrupt, we got to play with interrupts a little bit. We got to play with this device a little bit just to get the juices flowing, I'm hoping. You guys have any questions for me? Any comments? Were you able to hear? What font size are you using? You don't hesitate to tell me to make it bigger or smaller, but I go into settings and I go into editor and I can change the color and I can change the size. So what I do is if I want to change my color right here for my comments, because they don't show up well, I can make it whatever color I want. And then font size, and then my font size, I can do that, and I can make it as big as you want. So, good question. Do I have any other questions that I can help you guys with? Definitely make it so I can see it, and I can change colors to your heart's content. Okay? I appreciate you guys showing up. I really do. Keep you moving forward. It's nice to see some people interested in this stuff. Monday, everybody's got to be here because it's back to the grindstone. We all have to work our way through this. I know it's changing. It's hard changing professors in the middle. I wish you guys didn't have to go through this, but it's a strange world out there. So you know how it is. Write code. Be happy. Wash your hands. Okay, guys. I will see you on Monday.